Well,
thank you very much. Good morning, everyone. Thank you for coming for our presentation early this morning. So yes, my name is Léo Marchal. I come from France, but I'm currently a research associate in Chuo University in Tokyo, Japan. And today I would like to talk about this framework, open source GIS for placemaking education. So that's today's summary. So let's begin by the beginning introduction. First, I would like to have a word about Japan's participatory urban planning called Machizukuri, which means town making. Machi means town, and Zukuri here means making, which is a bottom-up approach, a Japanese way to plan some urbanism with a community. And over the years, it had evolved, integrating different digital tools, and more recently, it intersects with what we call gamification, which is integrating game mechanics to enhance learning and civil engagement. So, in a word, what is this Machizukuri participatory approach? So, it dates from the 50s or 60s, and the first generation was just councils, district plans, with different communities organizing together to improve their neighborhood. And second generation had different experimentation for community participation with different workshop, collaborative design. And third and last generation tried to have a more comprehensive management and focuses on long-term area revitalization. So the pros and cons are it brings a deep community engagement. It's quite adaptable, resilience, transparency through the different discussion. However, it might take some time to come up with some interesting ideas, to come up with a conclusion. It may be a potential for conflict, and participation might be unequal, as some person might be quite shy to properly express themselves. A quick word about what we call gamification of urban planning, how to consider urbanism as a game. So first, one of the goals of this framework is to make young people participate, but there are a lot of challenges for this. Young people might be indeed quite unconfident and reluctant to speak up. They also might have some mental health pressure, very difficult for them to speak. And about Japan, there might be according to some research, some specific shyness, specific passiveness from young students and young kids, making such participation even more challenging. However, a game, not only a video game, but a game overall, can act as a protective mediation, can help a lot of people, not only young people, but a lot of people to express themselves. So yeah, the strengths of such gamification will be a good learning experience to link a real development with a virtual space and to enhance the participation. And one of these characteristics of this participation will be once again to focus on the high school students and young people. The goal will be to propose solutions with 3D modeling and to not only focus on building but on public space. And so all this would lead to what we call tactical urbanism. So in a word, tactical urbanism is how to mix how to accommodate a certainty, and also it's some kind of informal development. So in a word, tactical urbanism will be the capacity to have a big influence on a big urban space with a minor decision. You can change a pedestrian flow with just a pot of flower. You can change the flow of cars with just painting something on the road at night. So minor intervention and big impact. So there is a framework called game-based learning, or GBL, and spatial thinking. And in a word, there are different reasons you should play games, and maybe video games, for example, that might make you a better architect. So there are many research about this. It can enhance your coordination, can help you discover inspiration, improve your perception, build a better personality, and most important, it's fun. Everyone likes to play a game. So there are also, besides the gamification game, there are different challenges for, once again, make young people to participate in urban planning. There is this ladder of participation created by Roger Hart 30 years ago, divided in two main categories. The 1, 2, 3 will be where the kids are mostly not involved. You begin with manipulating kids, just use them as decorations and tokenism. And then from 4 to 8, you really involve them. You really consider the opinion of kids. You really consider their needs. And that's how you can really initiate involvement in kids. So there are, of course, different initiatives about these GPL frameworks. The most famous will be the left one, the block by block, created by United Nations Habitat in collaboration with Mojang project, which is a creator of the video game Minecraft. So in this initiative, they were creating urban environment in Minecraft, and then they were asking professional architects and urbanists to translate them in the real world. Other initiatives such as Equicity, academic research that mainly looks like a video game, and other initiatives based on board games. Also Japanese initiatives with different books and catalogs about different games you can organize for this Machizukuri, Japanese town making, different catalog, and once again another Japanese initiative based on Minecraft. So the framework I would like to present today is based on the Godot game engine. So you surely heard about the two main actors about the software to make video games, Unity and Unreal Engine. But for different reasons, we chose Godot, which is free, open source, very light, about 50 to 100 times lighter than Unreal Engine. And it's getting much better, growing both for 2D and 3D games. So, of course, in a word, it's very important to use open source software. It's free, it's much easier to use, and much better for the community. So let's begin the main part, the methodology of our framework. So once again, the goal of our framework is to allow students to experience the value of urbanism and public space while enjoying 3D modeling software, video game software. So we believe it can strongly contribute to educate kids to urban planning, urban design. And we base our model to the ADI model, which is a framework for instructional design and training development, mainly for kids, but also for adults. So the phase 1 will be to analyze the situation. Phase 2 will be how to the first phase of design. Then we develop, we implement, and then we evaluate. So based on this ADI model, we have our own 5 phases. So we begin with field observation, we document it, and then we have a goal, mission-oriented design development. Then we have a collaborative modeling with Godot game engine. Then the phase 4 will be to have interactive exploration, and the phase 5 will be a questionnaire and reflection. So the framework will be 3 to 5 hours workshop. With the first phase will be a field observation. Here we have a first local proposal, which is the Minato Mirai in Yokohama, which is a quite unique and interesting place, quite difficult place to analyze, but quite unique as well. And so the first phase will be to use the open data of PLATEAU, which is initiative, open source initiative from the Japanese government. So we download it, we extract and export the necessary data on Blender, and then we import this data directly into Godot game engine. So the phase 2, as I said, will be goal-oriented, mission-oriented design development. It can be quite stressful to develop something out of nowhere without a precise goal, without a precise mission. So like a game, we can suggest missions. So mission 1 would be, please design a space with shade from trees. Mission 2 would be, please install benches that make people want to stay, etc., etc. So having such precise goal will be much easier and bring a peace of mind for the young kids. So mission could look like this: design a space with shade from trees, with different constraints, and we could attribute a certain score for each mission. And also, we have different difficulties for this workshop. So those difficulties will be based on the LOD, the level of detail. Here, level of detail defined by the PLATEAU initiative, from LOD 1, which is a basic model, to LOD 4, which is the most advanced level, including BIM and SIM information. But of course, as it is a workshop made for beginners and kids, the workshop scope will be only for beginner and intermediate level. So beginner level will be to just have a compilation of assets, just 3D objects we can just download and place. And intermediate level will be to use more advanced assets for advanced spatial composition. And then what we call gray boxing, the advanced 3D modeling, and then the advanced 3D modeling Blender will be out of scope here, too difficult. So a few examples of our goal, how to implement such a spatial composition. As I say earlier about tactical urbanism, here with only a few pieces of furniture, just a bit of paint, you can, with a very small intervention, you can really change the whole mood of the whole environment. So we can use different assets, different 3D models, and those models can be trees, plants, a character itself, different furniture, or even primitive shapes if you want. And we are using a plugin for Godot called Godot Asset Placer, and this plugin let us to drag and drop easily, very easily assets. You can rotate, scale them. We also proposing different categories of assets, either furniture, nature-related assets, or other primitive shapes for the first step prototypes. And so the idea will be to select an asset category, to place it, adjust its size, its angle, and then you can also, of course, modify the size. You can move, you can rotate each asset you placed. Here, for example, of missions completed. So you have to design a space with shade from trees. So you have to place trees, install benches that make people want to stay, etc., etc. So then, of course, the main reason we use game engine is to control a character. So here we chose a small, what we call kawaii, cute character for kids, but of course young adults and even adults like that kind of very cute and warm character. So you can just run around, you can just change your camera, you can jump everywhere, and then you can have a real feel of interaction with the environment you just created. So in the university, we created just a mock workshop with here adult students, so just to make sure that what we were trying to prepare was easy enough for much younger students. And before continuing the workshop, let me show you a video, a 3-minute video of this methodology that will explain maybe, I hope, better. Yeah, so we have our 5 steps, and we'll begin with field observation and documentation. So first we download and import the data directly into Godot, and here we are lucky enough to have a high level of detail. We add collision shapes directly into Godot because that's one of the main reasons you want to use a game engine. we just simply use a satellite view as a floor texture to have a clean and flat texture for the floor. And then you can use different street elements, different assets, different 3D models to transcribe the real environment with, once again, some cute and nice looking assets. So step 2 will be to define different missions, and then we begin the collaborative development on Godot. So we use the plugin Asset Placer, and really easy to use. You just have a catalog with different categories I mentioned: furniture, nature, and prototype. So you choose your category, and you, such as an easy catalog, you can choose a asset you want to place. So here, a tree, and you can just choose a position, and with different keyboard shortcut you can choose the size, you can rotate it, and once you're happy with it you can just confirm, and of course you can edit the asset later. And each of these assets has also collision, so you cannot go through the tree, of course. So you can create a simple environment within a few minutes. And then, of course, we go to the interactive exploration. And you can launch the game within few seconds. So you have this cute character. So you can, of course, zoom, rotate the camera, just have a better understanding of what you just created. And yeah, you can just walk around, run around, and jump around. And yeah, with a collision shape, it helps students to appropriate what they just created. And the 5th step will be to end up this workshop by handing up a questionnaire to the students. So yeah, we will just simply ask the students, do you have any interest about video games, computers? What are your IT skills? Do you have any experience with 3D software? And one of the goals of such a questionnaire is that we do believe you can learn many jobs with video game software. As an architect, I'm convinced that it might be one of the future for architects to use such software, and video game software year after year look like the software architects are using. And yeah, of course, we need to define the hypothesis and KPIs, the key performance indicators. So we need to analyze the data, the proposal of each student. We need to make proper comparison. And yeah, let's finish with a quick conclusion. So if we need to compare this workshop with this framework with existing workshop, I will say that it can provide a practical design experience combining real and virtual worlds. I think it can cultivate logical problem-solving skills through enjoyable mission formats. It's, to my knowledge, the first to use Godot. Thank you, 2 minutes. Godot as a software, and also to target very young people. So this framework, I believe, is quite rewarding because Godot is an open source, free, and very light software. So the participants, the young people, they can continue using the data at home and explain it to their family, friends, and share it with their friends. So future research we could do after this framework to refine it will be to work about accessibility. One of the main issues about an urban environment is to make accessible for everyone, handicapped people, wheelchair, etc. So we're wondering if we could include such aspect in our framework in the future. And also we would like to develop some kind of digital community with different avatars to enhance the citizen participation, especially from young people. So yeah, that's all for me. Thank you for your attention.
That was so cool. Oh my gosh. It was like open source for kids and urban planning and oh my gosh, so cool. Does anyone have any questions? Yeah.
Thank you for your presentation. I'm glad to use Japanese Plateau use case. So anyway, what do you think would be a better spatial scale use for your approach? Because in today's your approach using the micro scale. So, however, the Plateau 3D model data you mentioned about the LD 0, LD 1. So, of course, better used to non-skill student and charts. So, however, I wonder to gap technological and some Machizukuri's gap to yeah. So how do you think?
Thank you. That's I will take the mic. Thank you. Yeah, thank you very much for your question. Indeed, we chose, as I said, Minato Mirai in Yokohama. Here, and we were lucky because that was indeed one of the only places with LOD 3 with quite refined shapes and texture, and most of Plateau data is LOD 2 or even LOD 1, just white boxes, and this level of detail is, as you say, not good enough yet for micro scale. So we got lucky here, but that's indeed a challenge. We tried to download 3D data from Google Maps, but as you know, it's photogrammetry. So when you use 3D data, it's really rough, and we need hours and hours to clean this 3D modeling data. So yeah, for now, I guess we're a bit trapped in this framework using only LOD3 detail. And yes, that is one of the limits of the framework, because the definition of tactical urbanism I mentioned is micro scale, and yes, is really micro scale, and because we want young people, we want to have a rewarding framework. So if we can explain to young people they can change the environment with a micro scale, just putting a chair, just a bench, just a flowers, it's really rewarding and very short term. So in only a few days, they can change something. Yeah. However, the micro scale, the very large scale, is for now out of scope.